My name is Adi, and I'm going to present about unifying language models with knowledge graphs. First, I would like to thank a few people, especially Jacob Porschman from Google Berlin, with a lot of interactions we had regarding the graph racks and the knowledge graphs and language models. Milena Solomon, Michelle Schaefer, Anuradha, Lavanya, and Shiva, they all helped me during the interactions and about knowledge graphs and language models. So I really want to thank them. So what do we talk about this talk? The first part would be about knowledge graphs, a short introduction to knowledge graphs, and then about unifying language models with knowledge graphs, and in which there are three main categories. One is knowledge graphs enhancement of language model generation, and the other one is language models, using language models for augmenting knowledge graphs, and the third one is synergizing language models with knowledge graphs. So these are the three main ideas under the unifying language models with knowledge graphs. And then we will talk about evaluation and benchmarking of these ideas. And finally, the use case, why we are actually looking into this unification and what we are doing it, which is actually generating personalized educational pathways. So we are using these developments in the domain of education. And a quick summary and outlook to end the presentation. Knowledge graphs. What are knowledge graphs? Essentially, these are combination storage of information as entities and relationships, and of which the most important components are nodes, edges, and attributes. So nodes are all these entities, and edges are the ones how they are connected with it, and attributes are the properties which actually kind of describe these relationships. So in a sense, knowledge graphs gives much more contextual information and much more deeper, and it's much more efficient way of representing information. So that's why knowledge graphs are very powerful. And now we come to different knowledge graphs. So knowledge graphs can be of wide varieties, of which the most popular or the important ones are encyclopedic knowledge graphs, which is essentially from Wikipedia, where it's very clear how this information is connected. So Wikipedia is essentially a very big knowledge graph. And then there are common sense knowledge graphs, which essentially means that you can have a line of thought, and it's how you use common sense in general. So there you can always see how things are connected. And these are common sense knowledge graphs, which is for day-to-day ones. And then there are domain-specific knowledge graphs, which are of specific domains like medical domain or law, legal domain or medical domain, where you have a lot of concepts and you would have a connection between these concepts. So these domain-specific knowledge graphs are very powerful, but they are related, and each domain would have a different kind of knowledge graph. And finally, there are multimodal knowledge graphs. Multimodal knowledge graph essentially means that it's not just only text connected, but it can also include images, videos, and all. So it's essentially multimodal in nature. So these are the four different major knowledge graphs. And now comes language models and knowledge graphs. And what is the language models? What are its biggest advantages? Are its general knowledge, and it understands a lot of things. It has its amazing generalizability, but there are also problems with it. That means it can hallucinate a lot, sometimes indecisiveness, and sometimes black box, depending on what kind of models they are. And certain times you cannot adapt it to newer domains. So they can be very general, not specific. And so this is where the knowledge graphs now comes in. So the biggest pros of knowledge graphs is it has structural knowledge, accuracy, decisiveness, interpretability. So this thereby combining language models and knowledge graphs is seen as a potent combination, which can address which can be that knowledge graphs are guiding the language models, and language models in turn helping knowledge graphs to be complete. And in this combination, what are the different approaches? The first one is knowledge graph enhanced LLMs language, where knowledge graphs actually uh, uh, guide the LLMs to generate the output. Therefore, they are enhancing the the generation capabilities of language models, so that the knowledge graphs, the facts it contains, and the reasoning it has can be passed on to the language models. Thereby, it generates much more meaningful and much more domain specific. The other approach is the language models augmenting knowledge graphs. The language models also have a general knowledge. It can be used as something which can be used to collect the knowledge. So this can also enhance the knowledge graphs. So LLMs can be used to augment the knowledge graphs. That is the other aspect. And finally, the third one is actually a cyclic or a synergized combination, which is synergizing language models and knowledge graphs. So both these processes happen one after the other in a cyclic manner. So therefore, it's an synergized architecture. So yeah. As we said, we spoke about three different ways of unifying language models and knowledge graphs. Even in these three different ones, there are sub topics. So as you could see, first one, knowledge graph enhanced LLMs contains several subtopics like knowledge graph enhanced LLM inference, knowledge graph LLM interpretability, which is now look into then how do you integrate knowledge graphs into LLM inputs, how do you fuse, integrate knowledge graphs into training of the LLMs, and so on. The second one, LLM augmented knowledge graphs. It also contains like LLM augmented knowledge graph embeddings, knowledge graph completion, knowledge graphs construction, knowledge graph text, knowledge graph to text generation to obtain high quality text. So we would go through some of the aspects, and finally synergized LLMs plus knowledge graphs, which is essentially from two main topics. One is knowledge representation, and the other one is reasoning. So we would go through each of the some of the concepts. We will touch upon some of the concepts we have mentioned here. So the first one is knowledge graph enhanced language model generation. So here, as we mentioned earlier, so the knowledge graphs which contain specific domain specific information is connected with the language models, and these language models using the knowledge graphs as a base would generate do the generation, and thereby giving much better quality of the generated content. So in this context, what we come across is called graph racks, which is essentially the retrieval augmented generation, but it's much more advanced. And as we are doing it on knowledge graphs, it's called graph racks, where it can be more accurate and contextually aware and much more nuanced. So the example which Neo4j also has developed is that when a question is asked when a user asks a question, it goes through a knowledge graph which contains all the relevant information and does a vector similarity search, and then answer accordingly to this relevant information, plus the question asked, and generates the answer based on this relevant information. And this whole pipelines are called as graph racks. The normal racks are very common when they are used on a normal database, but in terms of knowledge graphs, it's the graph racks, and they are deemed as very powerful pipelines to generate much better information. So the second one is the LLM augmented knowledge graphs. So the general framework is that from the language model, which can actually used for knowledge graph construction also. So the language model tries to inherently understands so it recognizes the entities, the relationship between these entities, and also the properties. So thereby the standard text is analyzed by the LLM, and then the LLM converts that into a graph, therefore doing this augmentation of knowledge graphs. In that, there are two varieties. One is LLM augmented knowledge graphs for distilling knowledge graphs from LLMs. So the LLMs takes in all the tech information which is in the form of text, and then it distills into the triples, which is the standard format for knowledge graphs. And once these triples are distilled, then it actually constructs a knowledge graphs. Therefore, this can be used as or it can be used on top of existing knowledge graphs, or on constructing, building new kind of knowledge graphs or the fresh ones. So this is one variety of distilling knowledge graphs from the LLMs. And the second one is to generate high quality text and leverage knowledge from LLMs. So we take in the knowledge graph and use the LLMs to convert them into knowledge graph to text in order to generate much better and high quality one. And these kind of mechanisms can be used where there is very few data and extract this and convert them into high quality data. So this is also a powerful technique to generate um, text from knowledge graphs. And we come to the third approach, which is the synergizing LLMs with knowledge graphs. And as I mentioned earlier, this is mainly from perspective of knowledge representation, how you represent your knowledge, which is in the form of knowledge graphs, and the reasoning, which is something which you give the capabilities to the LLMs. So in this one, this is a general framework where you could see the data, all the structural facts, the text corpus or the textual data or the image or the video is given to this synergized model, which is comprising of LLM and also the knowledge graph, which takes the advantage, which combines the advantages of both LLMs and the knowledge graphs. And essentially, once this synergized model is done, then it can be used for different wide variety of use cases in which search engines, recommended systems, or personalized recommendations or personalized generations are one of the biggest applications. And the techniques can be the used techniques can be of several kinds, like graph neural networks, in context learning, few shot learning. You can also work on the prompt engineering and representation learning. So there are several techniques which then lead to several advanced applications. So this is a general framework how you can synergize language models and the knowledge graphs. And in the unifying, the key things is that the LLMs from the text corpus takes in the standard representation, and the knowledge graphs contain the knowledge representation in the form of knowledge graph objects and the LLM objects, and this can be used for training the language models and therefore combining building the synergized architecture. And because we are combining two approaches, one of the frameworks to do that is called Kepler, where you have a knowledge embedding combined with the pre-trained language representations. So as you could see, the knowledge graph provides these encoders, the embeddings, which can be used for calculating these knowledge embeddings laws, which will be combined with the normal laws, which is coming up from the standard text in the form of a language model encoder. And so these two can be combined, and a unified model approach can be obtained. This is one of the approaches to synergize language models and knowledge graphs. Yeah. So now that we spoke about the approaches, different kinds of approaches, how do we evaluate it? And one of the first evaluation it can be carried out by this open source framework called LLM KG Bench, which is a language model knowledge graph bench, which is automated and a continuous evaluation platform. As you could see, you could give the benchmark configurations and also the benchmark collections into this framework, and you can actually connect your language model, which is in the form of this API, to the AI. And this is actually a continuous process. So it goes depending on the number of iterations you give in, it iterates. And also it can give, finally, when it's done, it can actually produce stats, which you can see in the form of plots. And you can see actually benchmarking plots to compare and see how the performances of different LLMs are in this framework. And that brings to the first, what kind of tests they do. So one of the first ones is called fixing of errors in turtle files. Turtle files are a specific kind of format for knowledge graphs. It contains these RDF, and fixing of errors in the turtle files is one of the first tasks in the first task to test these evaluations. And in this one, in the fixing of errors, you give a wrong or missing ones in the turtle files and see how actually these language models fix them. And usually they have done it for the popular models like Cloud, GPT, and GPT-4. And as you could see, the higher the F1 scores, the better the performing they are. And then the second one is called knowledge graph creation from fact sheet, which is like you give a plain text and see how it can actually create a knowledge graphs. And this is also a powerful way to know how well your language models are synergized. And the third one is much more on the synthetic data. And it has two approaches. One is direct evaluation and the indirect evaluation. So the direct evaluation is essentially on the data itself, and the indirect is on the model. So in the direct evaluation, we look at the data, how good it has been generated, and you would then have also a human-based feedback to evaluate it. And also you look at different statistics, how diverse is the data, to just see directly how good the synthetic data is. And then there is also an indirect evaluation, which is that this synthetic data is fed into the model and you look at the results of the model, whether this model is doing it well or not. The standard one will be like a classifying or a reasoning of this model. So these are the two approaches to evaluate also the language models and knowledge graphs combination, thereby doing a direct evaluation and an indirect evaluation. And now comes to the use case we are working on, why we are looking into synergizing of language models and knowledge graphs. What we want to build is actually an education counseling tool, which is that it provides, based on the prompts, it provides personalized educational pathways. And the idea is that the students will interact with these language models, but not just only language models, but these language models are combined or unified with the knowledge graphs, which are of domain specific ones. So the students will interact with this language models, and then therefore they get these pathways. And we are using open source language models and knowledge graphs. So the pipelines are graph racks. Yeah. What does these knowledge graphs look like? The education domain knowledge graph look like? We don't have to start from the scratch. There are several knowledge graphs which are built, especially for university curriculum or school curriculum, or how these school and how can you recommend actually certain subjects to students. So there are several knowledge graphs built specifically for education domain. But what we need to do is we need to refine them. Uh, we need to make sure that they are updated and also modified for the use case we have. So therefore we can actually use these ones as a base level ones and then build on top of it. And the final one, which we have combined with the architecture, is that it's the knowledge graph and language models in combination. And the knowledge graphs will be guiding the language models, and the language models in turn will be filling the knowledge graphs or completing the knowledge graphs specifically for the domain of education. And therefore giving, so this path engine, the one which generates pathways for students uh, based on their interactions, which personalizes to their passions, interests, and skills, uses these knowledge graphs and language models in combination to generate these pathways. Therefore, it has a certain understanding and also reasoning. And we have an hybrid architecture which we built where we combine both graph and vector search. So we have certain pathway data which we use the vector embeddings to do a search, and we also have convert that into a knowledge graph using Neo4j and Cypher, and also use those use that graph embeddings too. So whenever a student asks for pathways, it's actually an hybrid approach. So therefore, it goes through both graph and vector search and combines these two and presents this uh, to the students. So This is the architectures we are trying. We are also trying out several other architectures, yeah, to develop this personalized educational pathway engine. So we will finish here by giving a summary, which is that knowledge graphs can ground LLMs. That means provide them context, limiting hallucinations and lack of interpretability. It can address all the issues which LLMs contain. And multimodality of LLMs, multimodal LLMs for knowledge graphs is also one of the most research topics. And because we are using knowledge graphs, which have low latency, which can run into a lot of issues on the memory. So there needs to be development of sophisticated algorithms to make sure that you can use these knowledge graphs with low latency and effectively. And then synergizing language models with knowledge graphs for bidirectional reasoning. That means LLMs reasoning for knowledge graphs and knowledge graphs supplying it to the language models. We are using it in the for the context of generating these educational pathways. I would like to thank again Jacob Porschman, with whom I had a lot of discussions on graph racks, and some of the references, especially most of the ideas and most of the work is taken from the paper, which is this, which is the Unifying Language Models and Knowledge Graphs, a very big roadmap. It's a very good article comprising of a lot of details about this topic, and also several other papers which contain essentially about language models and knowledge graphs in combination. So these are few references. Yeah, and thank you. That's one. We have actually a GitHub repo where we are making our developments open source, and we would also put in white papers about the combination, how we are synergizing language models and knowledge graphs for our particular use case of generating education pathways. So yeah, that's my contact, and yeah, I'm also active on LinkedIn and GitHub. Yeah, so this is my presentation, and thank you and have a nice day.
As today's sessions come to a close, I want to thank you all our speakers, and you, the audience, for shedding light on the most recent breakthroughs in NLP, LLMs, and generative AI. I would like to thank each one of you for your engaging questions and for sharing your experience and expertise. It's evident from our discussion that open source efforts and the community play a pivotal role in applying generative AI and NLP techniques in practice. The range of tools and models presented today, tailored to tackle real-world business problems and challenges, is truly inspiring. The accomplishments of the open source community this year have been impressive, and by all means, we are only getting started. We reconvene tomorrow at noon Eastern Time for day 2 of the NLP Summit, with a spotlight on the role of NLP in healthcare. We invite you to rejoin and be a part of this ongoing discourse and community. Wishing you a pleasant evening, and I look forward to seeing you all tomorrow.